So this is the practice quiz number 3. So here's this problem. We have the surface area of some weird shape. Is this formula the radius and the height? So it's given by that. And we want to keep the surface area the same, but change one of them, like change h. What new r do we need then? Okay, so there's two ways to do this. You could solve for it. You could solve for r as a function of h, and you'll find that it's impossible. You have to square both sides, you get r to the fourths, and it's a real mess. It's really hard to find r as a function of h. You could guess and check, plug in a new h of 5.18, what r would keep it the same, keep the surface area the same, but that's not very cool, and that could take a really long time. So of course it's better to use calculus. This is the implicit differentiation problem. You're going to have to do this implicitly. Okay, so that's the idea. We want to change h to 5.18 from 5 to find what the new r is to keep the surface area the same. We don't even need to know what the surface area is. We just want to keep it the same. Okay, that's kind of cool. Okay, so here's what we do. So in other words, we want r as a function of h. Change h, what's the new r? So r then is kind of like y. That's what we want. And we want to change h, so h is kind of like x. So if it helps you, which it helps me, let's just change those variables to x and y, and that'll just make everything seem a little bit easier. So our surface area, which is a constant, like I think it ends up being like 24 or something, but it doesn't matter, that doesn't change, is equal to 4yx plus 2 y square root of y squared plus 3. Okay, now we take the derivative with respect to x implicitly. So take the derivative with respect to x of this whole formula. Okay, so like I said, this is the implicit differentiation problem. Okay, this is a constant, that's 0. So we have 0 is equal to, we have the product rule here, derivative first, so derivative 4y is 4y prime times the second, plus the first, 4y, derivative x is 1, because remember taking the derivative with respect to x, so we don't have to write that, plus derivative of the first is 2y prime times the second, square root of y squared plus 3, plus the first 2y derivative of the square root of y squared plus 3, which is 1/2 y squared plus 3 to the negative 1/2 times the derivative of what's inside. Derivative of 3 is 0. Derivative of y squared is 2y times the derivative of what's inside the y squared, which is y prime. This looks like a mess, but it's not that bad. It's really not that bad. We want the slope. We want y prime. We have a point. Our point is h equals 5, which is like x, so it's 5, 1. That's our point. We need a slope, which is y prime. We want the slope when x equals 5, r equals 1. So we want this slope. So I'm just going to write that down. We want the slope when at the point x equals 5, that's which is our h value, and r, which is y equals 1. So right away we can plug those numbers in to save ourselves a lot of trouble. So let's plug in x equals 5, y equals 1 to everything up here. So x equals 5. We don't know y prime, it's the only thing left, so that would be 20. So now we have 0 is equal to 20 y prime. Y equals 1, so that's plus 4, plus 2y prime square root of 1 plus 3, which of course is square root of 4, which is 2, but I'm showing all my work, plus, okay, this is a tricky one, a lot of stuff going. We have a y prime, so I'm going to write that first. We have a y prime at the end. We have a y, which is 1, so the y's go away. We have a 2 times 1/2, which goes away, but we have a 2 here. 2 in the bottom, it's a square root, because it's negative 1/2, so square in the bottom of y is 1, of 1 plus 3. Okay, we're almost done. So that's equal to 20y prime, 0 is equal to 21 prime plus 4. Why did I write y there? That's a y prime. That's a y prime. Plus, let's see, that's 4. Square root of 4 is 2, so plus a 4y prime. Plus this last one, we have 2 divided by 2 So that's just another y prime. Did I do that right? So we have 2, those 2's cancel out, we have a 2 there. Yeah, I think I did that right. You guys aren't here to check my math, so I'm hoping that's alright. So 2 divided by square root of 2 is 1, so that's plus y prime. Okay, we can put this 4 on the other side, and I'm going to write it the other way. So we have 20y primes plus 4y primes plus 1y prime is 35. So 35y prime, and that's equal to, put the 4 on the negative side, negative 4, or y prime is equal to negative 4 over 35, which is probably some horrible number. 4 divided by 35 is 0.11428, 0.11429, let's say 0.1143. So 0.1143, and it's negative. Okay, now we just go, we have our point, and that's our slope. So here's our slope. So now we just do our y minus y1 equals the slope x minus x1. And again, our point was 5, 1. So y minus 1 is equal to our slope, negative 0.1133 x minus 5, or y is equal to negative 0.1133x. Negative times negative, so times 5 is 0.5714, so plus 0.5714 plus 1, or finally y is equal to negative 0.1133x plus 1.5714. Okay, that's our linear approximation. Now let's change x to 5.18, which is our new h. And remember, y is our r, so our new radius, if we change x to keep the surface area the same, is r is equal to negative 0.1133, our h value, which was our x, so it's 5.18 plus 1.5714, which is equal to, we're almost done here, 0.1133 times 5.18 equals that, negative plus 1.5714, which equals 0.9845. 0.98, yeah, about 0.9845. So that would be our new radius. And if our radius is that, and the height is 5.18, and you plug it back into the original formula, you should get that it's the same surface area. You should get about 24, and I'll let you guys try that. Okay, I use a lot of paper here, which is a good thing that I didn't try to do it on the quiz. I could have saved some room and everything, but anyway, it's okay to again not do the quiz on a piece of paper on the quiz sheet. You don't have to use a printer. Just do it like I did. Okay, finally, number 4. Number 4 is easier. That was the hard problem. Number 4 says you want to find use a linear approximation to find 1 plus 1/10 to the 10th to 2 decimal places. Okay, so we want to approximate this. Now, again, we find something that we know. Now I know what 1 to the 10th is. So what we do is we make up a function that y is equal to 1 plus x to the 10th. And we want to know what this is when x is equal to 1/10, or they always use the letter a, whatever. So I know what it is when x equals 0. It's just 1. Then I can use that approximation. We can find the slope and find an approximation to find out what it is when x is equal to 1/10, which is of course 0.1, such as it'll be easy to use 0.1, whatever. Okay, so our point then that we're going to go around is the one that we know. So we know the point x equals 0. When x equals 0, that's just a 1 to the 10th power, right? 1 to the 10th power, which is just 1. So y equals 1, so our point is 0, 1. We need a slope. Y prime is equal to 10 times 1 plus x to the 9th times the derivative of what's inside, which is just 1. We want y prime at x equals 0. So that's just 1 to the 9th, which is just 10. How easy is that? So then we do the y minus y1 thing to find our approximation. Okay, so our point is 0, 1. So y minus 1 equals, our slope is 10. 10 x minus 0, or y is equal to 10x plus 1. That's our approximation. So when x is equal to 1/10 now, which is our original problem, right? Our original problem is 1/10, so we make x equal to 1/10, which is 0.1. So y of 1/10, or 0.1, is 10 times 0.1 plus 1, which is just 1 plus 1, which is 2. And that's our answer. That's our approximation. Now, it's not a very good approximation. The answer is more like 2.5 or something, but it's okay. And the smaller we make this number, the better the approximation. If we put 100th in there, it's really, really close to the right answer. 1/10, yeah, it's not too close. Okay, that's how you do that. Hopefully that helps. Let me know if you have any questions, and I'm going to send out a regular quiz that, again, you don't have to do, don't have to print it out, just do it on a piece of paper like this, and it's going to be very similar.